identifying variables and being able to check that a variable has been isolated. So, what even is a variable? I have some fun videos that I'm going to put in the right-hand corner of the screen up here, so watch for a little eye. But a variable is basically something that can change in an experiment. And so if there's anything that can vary, that's where the word comes from, that is what you're looking for a variable. What does it mean to isolate a variable then? The word isolate means to put it by itself. And the reason why we would isolate a variable is to see what it does. If we change more than one thing, it's not really a fair experiment anymore. So for example, if I want to see what is the most effective way to grow some plants, and I have a group of plants, and I put half of them in the sunshine and half of them in the dark, that could be an interesting experiment on seeing whether the sunlight, my variable of light or no light, whether the light makes a difference in how the plants grow. But if I also changed whether I watered this one and I didn't water this one, and whether I gave this one nice rich soil and if I just gave this one sand, is that a fair experiment? No, I was really mean to this plant, and I was really nice to this plant. I should only change one thing, and I changed like 4. So I should only change one thing at a time in order to see if light was really making the difference, or was it water, or was it soil. So again, you're making it fair by keeping other variables the same. On that note, a controlled variable is what we call those other variables that we kept the same to allow another variable to shine. So our variable that shines is the isolated variable, and our controlled variables are helping keep everything else under control so we can really see if that isolated variable makes a difference. So there's another word too, dependent variable. We talked about how controlled variables are things we keep the same. A dependent variable is one that we can't really keep the same even if we try. For example, with my plants, if I put some plants in the light and some plants in the dark, I changed only the light and dark, and I tried to do everything else the same for the plants in every other way. I tried to give them the same amount of water. I tried to give them the same type of soil. Even though I'm being really fair by only changing one thing, the plants are probably going to change in a certain way. For example, the plants will probably, depending on whether they get light or not, grow taller or grow not very much. That height change is a dependent variable because it depended on what I did with the light. Another example is the amount of water you have left in a cup depends on how long you have been sipping from your cup. So the amount of water depends, so the thing that depends is the dependent variable. The independent variable is the one that we're isolating. I isolate, and you can also connect, that's the variable that I, the investigator, change because I want to see its effect. So independent variable in the case of our plants is the light. That's what I isolate. That's the one that I, the investigator, am changing because I want to see whether light versus dark makes an impact on how the plants grow. How can you see an independent variable and dependent variable when you're looking at a hypothesis? So here's one example of how a hypothesis might be written. Blank depends on blank because why? And we'd have an explanation here. So which variable would go here? So if you think about it, it tells us right in this hypothesis something depends on something else. So the one that depends, the dependent variable, depends on the independent variable, the one that I changed. Here's another example. You might say I think that if I do blank, then blank will happen because, and again, why? So if I do blank, then blank will happen. Blank will happen. This is going to be my dependent variable. And if I, the investigator, change this, that's going to be the independent variable. Okay, so why do you need to isolate variables again? This is Science 7. I separated it out to make it its own thing just because it's that important. If you only change one variable at a time, you can actually make a conclusion about what it did. If you don't isolate a variable, it's not fair. So, in summary, isolating one variable can help you see what impact it has on a dependent variable. To do this, you have to make sure that everything else about the situations that you're comparing is the same. In other words, you control all the other variables, the things that can change, and you keep them the same. So let's do some practice. We're going to try finding what the independent and dependent variables are here. I'm just going to highlight or underline what are the things that are changing. Does is not a word that changes. The size of the plate affect how much food people eat. Size of the plate, if I'm saying does the size affect, I'm going to be changing the size of the plate. Does it affect how much food? How much food people eat? And you could highlight the whole phrase, how much food people eat, but I try to just narrow it down to the most important words so that I don't get distracted. So now I just have to figure out which of these things am I, the investigator, changing? The amount of food people eat depends on the size of the plate. I'm going to go ahead and put how much food people eat depends on the size of the plate. So in other words, size of the plate is the independent variable, and how much food is the dependent variable. So those are the only ones that are actually written in the question. To think of the controlled variables, I'm going to need to actually kind of think outside of the box. And there are a lot of controlled variables because remember, controlled variables are everything that I keep the same. So generally, if your teacher asks you to do this, like me, I'm going to just ask you to think of maybe 3 or 4. But if you were really designing this experiment, you'd need to think very hard about what are all the things you need to keep the same in order to make this a fair experiment. So size of the plate has to change, so I can't put that down here. How much food is going to change, and I can't really control that anyway. But some things that I can control, I can make sure people are all the same age, because it wouldn't really be fair to have all kids using small plates and all adults eating big plates. Now I'm not testing the plate size anymore. I'm testing how old people are. I want to make sure that they are either all boys or all girls or an equal mix of genders. The color of the plate might make a difference. Maybe some plates make food look more appetizing. And we definitely, speaking of that, we have to serve the same type of food and then the same serving style. If we have a buffet on one group and we have plating the food for the people on the other, that's also not fair. So we want to make sure that everything's the same except for size of the plate, which we are changing, and of course how much food. That's a dependent variable, so we can't really control that anyway. Okay, so on this one, I've already gone and highlighted for you the things that are changing. When flipping a water bottle, does how full the bottle is affect how likely it is to land on its cap? How likely to land on its cap is one thing that's changing, and how full it is the other. Which of these do I, the investigator, change? Well, I, the investigator, cannot make the cup more likely to fall one way or the other directly. What I can control is how full the bottle is. And as a response, depending on how full it is, the bottle will be more or less likely to land on cap. How full the bottle is again going to be my independent variable. And my dependent variable is how likely it is to land on its cap. Some things that I should control. I need to use the same type of bottle. They need to have the same shape of cap. We need to throw it the same way. And we need to have the same experience level of the thrower because some people are really good at this. And me, I'm not so good, etc. So lots of things that we'd want to control. Does listening to music while studying affect students' test scores? We're looking for things that change. Listening to music implies that sometimes we're not listening to music. So that's an option. That's a variable that could change. And while studying, that's not changing because everyone's studying. But does that affect students' test scores? So that is also changing. The test scores could be 100 or 90 or 80 or all sorts of things. Independent variable, what am I changing? I am changing whether or not music is playing. I'm not changing the students' test scores. That's up to them. So the test scores depends on whether they listen to music or not, maybe. If this doesn't end up to being a relationship, it's still a dependent variable. That's okay. And controlled variables, it would not be fair if I had kindergartners in one group and fifth graders in another. So we want to have the same age or grade. We want to have the same test. We want to have the same time of day. If one class takes it before recess and one class takes it after recess, that wouldn't really be fair. Now we're adding in another variable that's changing. Okay, let's just do one more. So which brand of bandages hurts the least when it is pulled off? Brand of bandages implies that we are trying out not just the Band-Aid brand, but we're trying the Kroger brand and the Walgreens brand and whatever else. So that's going to change. And hurts the least. If one of them hurts the least, that means that there's going to be differences in how much they hurt. When it's pulled off, we're not going to worry about because, again, that's not really changing. Everyone's got a Band-Aid, everyone's getting it pulled off. Independent and dependent. Which do I change? Well, I get to change the brand of bandage. I'm not directly causing pain, hopefully. The brand is changing because of me, and the level of pain or no pain depends on what brand. If there is no difference, again, that's still okay. It's still a dependent variable, even if we find in our experiment that the brand doesn't make a difference. That's just as good of an experiment. So, controlled variables, I want to make sure it's the same type of injury and the same maybe age of the injury, because it wouldn't be fair if somebody had this really deep, awful cut and somebody else just had a paper cut that had been already healed for 5 days. And we want to use the same size of bandage. And maybe it's even on the same part of the body. My fingers are more sensitive than my knee. And we could probably think of several other things too, maybe age. So we'll kind of keep those things in mind, and we'd want to make sure that all of those things that could make a difference, anything that might mess up our experiment, is kept the same.